Okay. Can you write that down? Can you see okay? Wave motion. Got that? Yeah. Yeah. We have everybody.
Yeah.
Was everybody on time at 9 o'clock in cab?
Yeah, it was actually on time today.
Yeah. Shame I didn't get to experience it. All right. Oh well, maybe next week. Wave motion. So, a few things to look at, but this lesson is quite easy to begin with. First thing we need to talk about is that there are two types of waves. The first type is called progressive transverse, or that's also called an S wave. And the second type is called progressive longitudinal. That's also called the P wave. Now I wonder, well, I'll let you write those two down, and then we'll see if any of you know the difference between the two. I wonder if I can get some video here too, that'd be nice. Okay. Do you have no, not yet. Okay, do you have that? Yeah? Does anybody know what type of wave a transverse wave is? Yeah. How would you put that in words?
It's neutral.
They both kind of do. Okay. Similar. I'll try and get a little video here to help you. Actually, yeah, this video seems nice. I think I just need to plug this into the computer. Let me just show you. So I'll show you a little video, only a few seconds, of an S wave. Come on.
Doesn't that TV accept HDMI?
I think, yes, of course it does, yeah.
How about the computer?
Ah, good. Now, can you see this here? This is the first type of wave. This type. What you were showing, Dorian. Yeah? That's an S wave. And then the other one, the, longitudinal wave. See if I get an animation of that. Oh, look, here's both. That might be better. Right, so can you see the difference between the two? It's kind of hard to see with the P wave.
Compresses? No,
Yeah, compression.
Compresses.
I'll show that again. It's kind of vibrating out, the P wave, the longitudinal wave. Yeah? So, let's try and put this into words. Well, actually, just before I do, I want to give you some vocabulary. No, I'll give it to you in the definition. Is that right?
Where could you find that P wave
That's what we're going to talk about. Examples.
It's like when you impact quantifiers.
Like what? Vibrations. Yeah. Are we back? Yeah. So, a progressive transverse wave is a moving wave that is made up of oscillations. You know this word, oscillations. And what's key here is that the oscillations happen perpendicular to the direction of energy transfer. So for example, if the wave, guys, can you look at me 1 second? If the wave is moving towards you, then the oscillations are perpendicular. Do you understand? So for the exam, they really want to see, the key word here is perpendicular. Okay? Okay, you got that? Okay. You got that? Yeah. Continue. Yeah. So, next one. The only well, what would you say is the difference in the next one?
Well, the other one, the compression is in the.
Yeah. But what would be a key word that has changed? Perpendicular has now become parallel. So, in a progressive longitudinal wave, the particles do not move with the wave. The particle movement is parallel to the direction of the wave propagation. Wave propagation just means where the wave is moving. This means that the particles move left and right, which in turn make other particles start to oscillate. This creates a wave. So the key word here is parallel. So you were saying about compression and expansion. That's what I'm saying here when I say left and right. So you have one wave or one particle that vibrates, it knocks the next one, and that starts to vibrate, and that knocks the next one. So they kind of move off like this. Yeah, see, the waves has lots of writing vocabulary definitions in it, which is why sometimes students don't like it. Oh, okie dokie. Yeah. Now, like I said before in semester 1, you don't need a word for word copy of a definition to get the marks in the exam. Key words here would be, of course, parallel in the direction of the wave, and oscillate. Like you expand, contract, neighbours colliding, oscillate, and all this kind of stuff could be used. Continue. Yeah. Right. I showed you the video, but here's another example of the difference between the waves. So in this example, it's like you have a spring attached to the wall, and you apply energy parallel to the wave. So I think you can all picture this. It kind of oscillates along, bounces, goes back and forth like this. Okay. Whereas in this one, it's like a rope that you wave up and down, and it goes up and down like that. These are the two different ones. Now, the waves have a name. Well, sorry, parts of the wave have a name. So the wavelength It's the distance from the crest to crest, or trough to trough, or indeed, you know, one point to the same point later. It's the wavelength. And like I said, here at the top is a crest, and here at the bottom is called the trough. The amplitude is the maximum displacement from the equilibrium position. Okay, so yeah, you could call this max and min and peak and valley, but the proper word is crest and trough, and I'll try and use those words. Could you draw this? I'd like you to draw this into your notes. Okay, you got that drawn? Not sure. Yep. Yeah. Yeah, because with waves, there's kind of two motions, isn't there? There's you can imagine the wave moving out from a source, but also it's vibrating as it moves out. So we usually say distance to mean how far the wave has moved, and displacement, its oscillations. Yeah. Okay, do you have that drawn? Yeah? Continue? Zach? Yeah. Now, some letters. So, X will be our displacement, amplitude, usual, A. Wavelength, lambda. Period, same, T. And phase difference, phi. The time difference between the crest of two different waves moving together. Now, I will have to explain this one. Frequency F, you know what this is. How many cycles in 1 second? So, what's the unit for frequency? Do you remember?
Hertz.
Hertz, yeah. And wavelength, what do you think the unit would be? Look at the definition. Meters, yeah. Amplitude's unit? Meters. Displacement? Meters. Period? Seconds. Phase difference? Seconds. Now, I think all of these are pretty clear, except maybe phase difference.
How much time does it take to go from crest to crest?
No, that's the same. That's period, actually. So there's something a little different. We'll let's see. Oh, and sorry, speed v. How fast the wave is moving. Meters per second, yeah. Now, you don't have to write everything down. What I would like you to write down is all these words. If you feel like there's one of them you don't understand, then you can write the definition down. Okay? So, well, some of them I hope you don't need to write down, like speed. It's a problem if you forgot what speed was. That's a big problem.
What is the Greek symbol for phase difference called?
Phi, I think. Check. I think that's a phi. Is it? Or is it a psi? It's one of them. I think that's a phi. Let me have a look. Okay. You got that? Yeah? I still see people writing. Okay. Can I, no? Are you writing everything, Diego?
Just, yeah, a few, like, not everything, but
Right, well,
small idea of each thing.
that's fine. While you're doing that, I'll look up some memes.
How about big nine?
Well, see what the latest memes are. Are we all just waiting for Diego? Yeah? Exciting. What I'm going to do now is try to draw a picture, a diagram, to help explain the phase difference. Or actually, maybe I could try and explain everything. Can I continue, Diego? Right. So, look, the first one, displacement. So, let me call this point here A. Maybe the wave is moving to the right, like a water wave, you know. And then maybe here is B, for example, and here could be C. You could say that's the displacement at A, XA, there's the displacement at B, there's the displacement at C. Yeah, something like that. Okay. Amplitude. Amplitude would be roughly here the displacement at B. That would be amplitude there. Wavelength, okay, wavelength would be that distance, be the wavelength, okay. Period, so it's hard to draw, but if you're standing here and you have a little watch and you see this wave coming in, you start the watch when the crest passes you, and then you stop the watch when this crest makes it over to you, if you can picture the wave moving. Like an ocean wave, okay? So that's the time. The frequency is what you do is you count how many crests passed you. You count the number of crests in 1 second that pass you.
Isn't it also 1 over t?
And it's also 1 over t as a formula. Yeah? The last, and the speed is how quickly the wave is moving. So for example, if you stick a little boat here, there's my boat, and it's on the top of the crest, and it'll be carried by the wave. The speed is just how fast the boat is going on the wave. Yeah? Assuming that the boat stays on the crest. Or maybe more accurately would be a surfer. There's my surfer. On the surfboard. Okay? But the last one, the phase difference. Let me draw that. So usually what happens here with the phase difference is you have two waves and they start at the same place. Ooh. Sorry, it's a bit messy. And you notice that the two waves, they're moving together. They're not quite lined up though. The phase difference is this here. Okay, that's the phase difference. You could say it's the difference between the crests of two different waves. Okay, that's the phase difference.
But it's time at a point, and which is the reference point?
Well, usually the two waves are identical, except one is slightly ahead of the other. So it doesn't really matter where or when you are, because even if you were to pick like here, like it looks like the blue one is ahead of the black one, or the black one is behind the blue one. But even if you were to pick this point, you know, it's still the same. It's still the same phase difference. It just don't have to look at the crest. It's just easier to look at the crest. I'm not sure what you're getting at, Zach, though. It's okay? It's okay? Is this okay, guys? Yeah? Yeah? That's the phase difference. Now, we have some equations. Some of them you know already. Zach, you mentioned one of them. F is 1 over T. But we now have a new equation called the wave equation, and that is V equals F lambda. Okay, you got that? You all got that? Yeah? Continue. Now, in the exam, they sometimes ask you for examples of each type of wave. So I wonder if any of you know what a example of a transverse wave could be. I already mentioned one in my example earlier. The ocean wave, yeah.
Light, sound.
Yeah, let's look at them. Not
Okay.
sound, actually.
No, sounds.
Light waves, like from light bulb. Ocean waves,
An impact.
which way?
If you see an impact here, and this could move a bit.
Oh yeah, so that would be kind of like surface ground waves for an earthquake. Yeah.
So all electromagnetic radiation.
Yeah, but that actually is a separate lesson we'll do. Waves in a guitar string.
Yeah.
Yeah. These are examples. Oh, there's many examples. Your one here, you know, if there was an impact, like a rock from space hits the ground, the energy would move out, I would think, like a transverse
So
wave.
it also like, you know, if you throw something to a fabric, you know,
Yeah,
you see like
yeah.
in slow motion.
A football net.
or
A football net when it's struck by a ball.
Or drop
Yeah.
in water.
A drop in the water, yeah. That's very similar to ocean waves. Yeah. Now, what about longitudinal waves? Sound is an example of a longitudinal wave. So as I'm talking to you, what's happening is the air coming out of my mouth is vibrating. And then this makes the neighbouring air particles vibrate. And then the neighbouring air particles vibrate. And then it hits your ear, and your eardrum vibrates on the inside. And then your brain turns that back into words. Yeah?
The 3 bones, smallest bones.
Oh, that's right, they are the smallest bones in the body, aren't they? In the ear. Yeah. The sound wave.
Hammer.
Oh, I have no idea. I can't remember. The sound wave moves outwards like this. So this is why it sounds quieter further away, because what's happening is the energy is being spread over a bigger distance as it moves out. So this is why it would sound quieter further away. Yeah. Does anyone know any more examples of longitudinal?
Is something false?
You want something being pushed nearly, huh? Yeah.
Or like with materials, really.
Well, I'll give you one. Underwater waves. So not waves at the surface, but underwater. For example, if there was an earthquake underwater that caused the water to vibrate, the wave would move out as a longitudinal wave. And then maybe when it gets to the surface, it could become a transverse wave. So underwater waves are longitudinal.
Is that why when there is that tsunami, all the water goes off of the coast and then comes back as a wave?
Oh, I don't know. I'd have to look at a little video, an animation or something.
You see what I mean? Like,
Yeah, I get what you mean.
like sea dries
I
up
guess
and
perhaps if it's vibrating, then just before it hits land, it gets compressed
so
before it expands.
like all the water comes out.
Yeah.
And then
Maybe so. I'd have to watch a little video animation. And one more. We really need 3 examples. Any more do we know? Sonar, yeah. Sonar's a sound wave, and it's just a sound wave underwater, yeah. Last example, just waves in a spring. You know, like a car suspension. When the car hits a speed bump, the spring, the energy moves like a wave.
Yeah, but it moves through the coil, and the coil is not exactly parallel.
No, but the wave motion of the coil. Do you know what I mean? Like, if you strike the spring, it goes like a wave. Basically, simple harmonic motion. Let's see, what else could we see? I think heat energy inside something moves like a longitudinal wave, you know? So like if I had this table here, and I like my laptop, you know, the bottom of my laptop is warm, so it's putting heat energy into the table. That heat energy, I think it moves like a longitudinal wave through the wood. Yeah. Oh, we have a separate lesson on these electromagnetic waves. Yeah, that's what Zach was mentioning, because they're a very special type of wave. They are transverse waves, I think.
doesn't heat depend on the material?
Ah, yeah, but it'll still move like a longitudinal wave, I think, because in physics at university, the equation for the wave, I think, is the same equation for the heat movement in a body. It's the same equation. So, I think, maybe I could even get a video. It's a great thing about YouTube. There's always an animation video somewhere. Dudes, be nice to each other.
It's one of these things that keeps going off. I think it's just drinks. Bought them for like €2 a pair of 3.
Keep it, throw it away then.
Because that's still stuff in there. Not using it.
Zach, stop bullying Diego.
Not bullying him. Giving him
Yeah,
life,
you are.
Giving him a life advice.
Life advice of what? Don't need any advice.
I can't find a video. It's okay. Maybe I'll find one later. Okay, can you write those examples down? Because sometimes in the exam they ask for the definition and 2 examples. So it's good if you have 3 in your notebook. Did you write them down then?
Is it correct to say light is just a wave? Because it behaves like a wave, but it's not really a wave.
Depends what you mean by just. No. No, seriously, like, when you say just a wave, what does the just mean?
Mutually exclusive
For what other possibilities?
from being anything else, a particle.
I wouldn't say it's just a wave. It's very hard to say. It's very hard to say any physical thing is just a wave. Wave is a behavior.
Yeah.
So, like, when you have an ocean wave, you don't say it's just a wave, because you need water molecules. Do you know what I mean? Or when you have a sound wave, it's not just a wave. The wave is describing how the air is vibrating. Now, I think I know what you're getting at. There is something special about longitudinal or electromagnetic waves. I can't find a video. That's okay. Right, continuing. So let's have a look at an example. A boy is sitting in a boat which is tied to the dock. The boat bobs up and down at a rate of once per 2 seconds. The boy judged the distance between the crests to be 4 meters. How fast are the ocean waves moving? So I'll just draw a quick picture and then we'll go back to the question. What the heck? Come on. Oh dear. What's happened? Yeah, here we go. Okay. So here's our ocean wave.
Once every 2 seconds.
So 0.5.
Yeah. There's the dock.
0.5 times 4.
And then here's the boat. And it's tied to the dock. I don't want it moving left or right. I just want it moving up or down. So as it's tied, it's just bobbing up and down. Now let's go back to the question and see what information we can get from the dock. From the question. The boat bobs up and down at a rate of once per 2 seconds. So what is that telling us?
Frequency.
Yeah, the boat bobs up and down at a rate of once per 2 seconds. So really that's telling us the t. The t equals 2 seconds. So the f equals, yeah, hertz. Okay. The distance between the crests is 4 meters.
Wavelength.
Yeah, so the distance between the crests, that's 4 meters. Yeah. How fast are the ocean waves moving? So these waves are coming in, they're going to hit the dock and then maybe they move back out or they just sort of dissipate, it doesn't matter. But the waves are coming in.
2 meters per second.
Yeah, well, if I want the V, I can use my new formula. Pretty easy. So can you write that example down? Do you need the question or
Yeah,
do you want
a few things.
a few things in the question? Yeah. Did you use the database for studying over the break? How useful was it?
Yes.
Did you use it for maths and physics, or just maths, or what?
It's mostly maths.
Mostly maths?
Yeah.
I used for physics and then we random.
Random question? Yeah.
I don't know, maybe a good feature would be if you could generate like 10 questions at a time.
Yeah, like
Instead of generating the entire section.
10 random questions.
Yeah.
Oh yeah, okay, I could add that in.
Instead of like when you click and it creates all the questions that are for that topic.
See, the only problem is I don't know if every topic has 10 questions.
Yeah,
Mm.
yeah, some do.
Right, do you want the answer? Answer?
yes.
Yeah. Okay. Okay, you got that? Yeah. Let me just check what the questions are like. I might want to do a couple more examples with you. Oh yes. I want to do this one with you. Okay. Guys, I'm going to just give you a couple more practice questions. And then there's something interesting I want to do with you, which you might enjoy. So, I'll just give you a couple of small, quick questions just to try here. Just to do right now. Do you know what a tuning fork is? Have you seen these before?
What?
A tuning fork? Yeah?
Oh, yeah, one of those.
Yeah. What's nice about the tuning fork is the frequency of the sound is printed on them. So this one is a 15 kilohertz. And the sound, does anyone know what the speed of the sound wave is? It's about 330 meters per second. It depends on many things. But anyways, we'll take it as 330. So quick question for you. Give me the lambda, please. Yeah.
Kilos times 3, right?
Kilo is down.
0.22.
0.0 to 2.2 centimeters. So you can picture that's how big the sound wave is at this frequency. It's kind of a short wave. Well, it's 2 centimeters. Okay, now I want to, well, I can say it here actually. What way, go back please. When sound has a different frequency, how do we perceive that? So, if some sound wave has a higher frequency, how do we describe that sound?
Has a higher
The pitch, yeah.
Like it's more.
Yeah, and a lower frequency,
Lower.
deeper, yeah. So humans can hear frequencies up to about 20 kilohertz. So if the sound wave is more than 20 kilohertz,
Just gives you a headache.
possibly, we can't hear it.
Ultrasound.
Yeah, ultrasound, yeah. But some animals could still hear it, like dogs, for example. Likewise, I can't remember it, but there's also a minimum frequency we can hear. And if it's too low, we can't hear it. Roughly, actually, I have it here, 20 hertz. So if the frequency of the sound wave is lower than 20 hertz, then we can't hear it. But again, some animals could hear it. I wonder if any of you know what animals can hear the very low frequency.
Elephants.
Correct, elephants, yeah. So for us, our sound wave range is between 20 hertz and 20 kilohertz. Okay? If you want to be hearing less than this, you need to be an elephant. If you want to be hearing more than this, you need to be a dog.
Whales can also hear quite low waves.
Whales.
Yeah, whales.
Yeah. It seems to be that the low frequency is good for animals that need to communicate at a distance.
Yeah, they can actually communicate
Yeah.
over huge distances.
Yeah.
So
Whereas what's useful about the high frequency,
It's very loud, usually.
yeah, I think it's good, like bats use it.
Oh yeah, so
Yeah, for location.
echolocation.
Yeah. But this here reduces with age.
Yeah.
So as you get older, this limit reduces. Okay. So what I like to do is I have a video, plays the frequencies, and usually the youngest student is the one that can still hear it. So
I've been to too many music festivals. This is not going to go.
it's not going to work. Let's see.
That's gonna make 4 of us feel very old.
Well, I don't know. Actually, this computer has sound, doesn't it?
I'm the only
Yeah, on the TV. Oh no, but you have to plug in the 395 millimeters.
Zach,
But
it's your birthday?
sorry,
Yeah,
Zach,
yeah.
what do I need to plug in?
September 5th.
But it has a HDMI.
The one that's
Wait,
dangling.
who's
in
when?
the
It was
inside.
15.
Where? Oh, here.
Yeah.
Ah.
Green one.
15, 25. You know how my house turns out. Priscilla's
Thank you.
on 22nd.
Okay.
Antonia's on 23rd and I'm on 25th. April.
That's gonna be a good weekend.
Is this gonna be a big party? Half the house, literally. Half the house gonna have a hot bucket.
How do I thought I could have both projected at the same time.
Okay,
Duplicate.
kind of. Like I actually, we don't talk that much. I don't talk much to anyone else. Busy. Tired.
You're busy.
Busy.
No.
I'm here. Doing my life.
How do I know if I have sound? Do I,
Started it.
Now
should I
it's
pick this one?
No, I think that's off the sound of the.
This one, you think?
graphics card,
Oh, maybe the TV's muted as well.
Yeah.
Oh, because I usually mute it,
just
don't I?
hear static, yeah.
There's,
Play something to see.
yeah, well, let's just see.
This internet is quick sticks.
Come on.
So,
I know, but I can give it to you
but you
afterwards.
open.
Oh, look, there's a picture of what I was talking about. So if you have a little incident underground, the wave spreads out
Yeah.
as a longitudinal wave. Why isn't this searching when I click search?
Searching by
Because
Edge.
Microsoft Edge.
Why would you do
Look at the red bar up top. Yeah, that's searching.
Do I need to use my hotspot? Is the internet too slow here?
How much data do you have there?
Unlimited.
Oh,
Because I'm with Gomo. €10.
yeah.
What's going on?
He's trying to be smart.
Yeah, trying.
I don't have
Right.
to try
Let me see. I'll connect to my network.
Harry, if you don't win this, then you know you've been at too many nightclubs.
Too much raving.
Who? Harry?
Yeah.
He's a minor. He hasn't been to any.
Technically.
Is this still recording?
It is, yeah. Right, let's see.
No, oh.
And there's ones that tell like, the age of your eardrums and stuff.
Well, that's
If
what they
you
do
hear
with-
up to a point, yeah.
When you go to the doctor, I don't know how you call it, the guy that checks your ears, he puts that like
So,
We
Yeah,
so
no,
what
this is
if,
right.
so what if someone also hears it? So does that mean that our body just ages slower or
Say again?
faster? Like if someone, let's say they are the same age, and some of them can hear, some of them can't hear. So is it just mean that your body just ages and like
You've been listening to too much stuff.
Yeah, your
Yeah,
ears
yeah.
are just fine.
I don't know, sometimes,
like the way your body ages.
yeah, but sometimes there might be a genetic thing to it as well.
That's true.
Like, oh, I can't remember. I had one girl maybe 3 years ago, and she was able to get a very high frequency, even more higher than the other students in the class of the same age as her. You know, so I do think there must be a genetic thing to it. Oh, come on.
Someone's downloading prawn.
I think it's too much Pirate Bay on the GHR network. Maybe, I don't know. Does any of you have a good internet signal at the moment? You could make a hotspot.
I can
try.
I can
Mine is
hotspot
also,
you
mine is
because
also
I have
unlimited. So.
I have 30 gigabytes with Vodafone.
Giga.
Gigabytes still. En España ping pong.
I can have.
Gigabytes.
That's what they use in Spain.
Gigabytes.
Yeah. No, it just reminded me of that movie Back to the Future. Yeah, because for some reason in the movie the scientist, he's American, but for some reason he pronounces it gigabytes instead of gigabytes. And it's almost like,
Connect to my hotspot if you want.
which one is that?
It says it's there or something. I found it.
There you go. iPhone Diego. Right, iPhone Diego. What's the password?
Is it locked? Do you not change the password?
Yeah, I did.
Where is it? Uh huh.
Why don't you just make it big?
I love Zach. Okay. Right, let's see how fast your internet is on your network.
Don't name my iPhone.
Ah, that's better. That's better. Yeah. Okay, are you ready? I think this might have sound. Let's see.
Is it gonna hurt our ears?
Pain is part of life.
No.
Ah. Maybe this one?
Yeah.
Yeah, no.
Take another video, like a normal one, to see if you have sound.
No, we definitely don't. You should be hearing it now. Do I need to change this to HDMI mode maybe?
No, because it's.
Maybe that's not plugged in.
Is this cable even plugged into the TV? This one.
Oh.
Yeah, it should be. It's a small one.
It is.
Is there like two of them? I think there's a yellow one and a gold one.
Yeah.
And usually you have to like stop the TV and
It's in.
so try it. Did you try the other one? Otherwise the one.
I'll try the other one.
The now it says no signal.
Oh, but that's because I switched it to HDMI.
There's
Actually,
no,
where is the HDMI? Is that not plugged in?
there's no HDMI signal from the PC.
There is not.
Yeah, it's only the DVI, and DVI doesn't carry sound.
Alright, so VGA back to.
It's DVI actually. VJ is the blue one. No, there you go.
Are you sure it's in? You sure it's in the right one here?
Yeah, yeah. And the green one exits.
It has to be the green one.
Yes.
What about the blue one?
You can try. Pink one is for mic in. I think pink is mic in, blue is mic out, green is sound out.
No problem. It's okay. I'll just play it on my phone. It should be loud enough.
Can I stop the hotspot?
You can stop the hotspot, yes.
Well, technically, I'm your father. No wonder you. Return to the future.
No. This is the truth. I'm a parent.
Oh, maybe
But the sound does work before, if I remember.
Yeah.
Lorraine was using it the other day. Well, before we broke up for holidays.
Oh, did you break up? Oh, yeah, no. Oh, she's gonna hurt the recording.
no.
She was so involved.
Okay. Probably can't hear anything yet. Frequency still too low. Still too low. Actually, make sure I do have sound. Huh. Maybe it's
Maybe it's
Maybe this
video.
video is.
Yeah, check
yeah,
check
yeah,
out.
yeah, maybe it's the video. Sorry, yeah.
Check the blue one out there. Oh.
But that's only 2020k. Should I try or write something?
Yeah.
Well, what should I put in?
Well, let me just check this video. Oh yeah, here we go. Sorry. Yeah. Okay. Now. Right, I'll stand here.
Stop.
Okay. Oh yeah, here we go. Take off. Right, so that's 1.5 kilohertz so far. Too loud? I'll turn it down. 3 kilohertz, you can all still hear?
Yeah.
4 kilohertz?
Yes.
Yeah. Be strong. 5 kilohertz, can you all still hear? Yeah.
Oh.
6?
Yeah.
Yeah. I'll turn it down. 7?
Yeah.
8? 9?
Yeah.
Okay, I'll jump it up a little bit. 13?
Yeah.
Yeah. Oh, wow.
Well, that feels weird.
Now, for me, it's getting really hard to hear this at 15.
Oh, wow.
I can still hear it.
Wow. How much is it now?
16?
Uh-huh.
Now, actually, what's happening is
The speakers.
my speakers can't handle this high frequency, so I have to stop it.
Oh.
I can still hear it.
Huh?
I can all still hear it.
Yeah, it's well, I wanted to see when it gets to 20.
Yeah.
So I would feel like, but my speakers started to break at that level. I think I probably can't hear 20, but you could probably hear 20. I think. But this speaker isn't strong enough, and I don't think this is working.
Oh.
Wow, it wasn't that bad now, was it?
No, I don't.
That's wrong.
Sound.
Does anyone else get like a ringing in the ears for no reason at all?
Oh, that happens sometimes. It just happens.
Okay, so look, I recommend when you go home and you're at your laptop, you can type this in, and I would feel like I think all of you could probably get up to the 20.
Do they
So-
go over 20?
This video doesn't.
Are high frequencies used for like crowd control or
Yeah, So there's a video that I played that apparently only teenagers can hear, and it did work. I couldn't hear it, but some of the students could hear it, and it's a sound that they sometimes play to annoy teenagers to get them to move away from shops or something. Yeah, the underground in London sometimes use this sound. So there's groups of teenagers just hanging around. They play this sound, and it sounds like, obviously I can't hear it, but the description of it and what my students told me as well is it sounds like a fly is just trying to get at you, but I can't hear it, you know. So
What frequencies? Is it a high frequency?
the teenagers can hear the high frequencies, the adults can't.
So it can also be used for like wars and stuff. Just to
The US military looked into making weapons based off of sound, but it just didn't really work out, so it's not viable. Okay, there's only one question for you to do in the homework, so I want you to do that question now and then you can go.